Alright, in this video we're going to calculate surface area using the double integral. I'm just going to run down real quick the theory behind here is you want to find the area part of a surface S. We do so through looking at parallelogram regions, and we go ahead and we add up all the delta t regions that we find. And here's our formula as we take the limit of those delta t's, and we're going to end up with a surface area. The book explains how this is calculated. So we do have that those a and b vectors off of a corner of pi, and then you go ahead and do the cross product of those two, and we end up getting, with the cross product and the absolute value, we end up getting those delta t values, and it turns out to be the square root of partial x squared partial y squared plus 1 square root of that delta a. So I'm just doing a little hand waving, getting this done quickly. Now I'll just go through the example that we need to do. We'll be hitting 15.5 again when we go ahead in module 5 with polar coordinates. So you can look back again, you'll have some time. So I have you do a couple problems without the need for polar coordinates for module 4. So now, moving forward, we end up with what we just want to get to here is this formula. So this is the formula you're going to be using for finding surface area. So that's the double integral, and again we have these delta t's here. And moving forward, you'll be looking again at this formula for, and this is an important formula of, down here, for the arc length, right? So it's very similar type formula, and you'll start seeing those connections once you get more into looking at the arc length, and when we get into actually doing line integrals. So what I want to do is just go through the example we have here in the slides. So it says find the surface area of the part of the surface z equals x squared plus 2y that lies above the triangular region T in the xy plane with vertices 0, 0, 1, 0, and 1, 1. Alright, so this is nice. The slide kind of just shows us the picture of it. And we have a region T shown here. This is figure 3 in the book. And we've defined that region here. So x is defined between 0 and 1, and y is bounded by 0 to x. Right. So we just plug in the formula. We did partial x, partial y, squared those, added 1, square root, iterated derivative. We went ahead and plugged in the 0 to x and 1, 0, 1. We can now go ahead and integrate. Integrated again, and we solve. So here's your solution for that. And you'll see, if you were able to graph this, this is the portion here. This surface here is the surface that we actually calculated the area of. So it's pretty neat. We can do that. So that was just a really quick video on calculating surface area. Make sure you know that formula. You've got a couple problems this week to do, and then at least one problem to do next week on this using polar coordinates. All right, good luck. did I not? What happened?